Hello and welcome to CS264. This is lecture 14 and this is lesson 5. I'm John Keating and today I'm going to talk to you a little bit about the solid principle called the dependency inversion principle, DIP. So in this one, and it's the fifth and last in the set that we've been looking at, we see that high-level modules should not depend on low-level modules. It's the key message. Both should depend on abstractions. Abstractions should not depend on details, and details should depend on abstractions. What this tells us really is to try to keep our high-level module and our low-level module, high-level class and low-level class, as loosely coupled as possible. And in other words, classes should depend on the abstractions instead of knowing about each other and knowing what's happening inside there. So for this example, we're going to return to the earlier SRP example where we use this output formatter class. And let me go there just to show you. And we had this output formatter class that contained these methods here. It was fine. And we used this as a solution in SRP so that we didn't want to be able to have all the information about printing when we calculated total area. We wanted to make sure that we had single responsibility here. So this method here wasn't in this class wasn't calculating the area and writing out the area, because we may want to write it in different ways. And then if we wanted to change what we wanted to write, then we'd have to change this class. There'd be lots of reasons for changing a class. So we didn't want to do that. So I'm going to return to that example because our high-level client was dependent on the functionality provided by the formatter. So to output the information using different formats. Okay, so that was the basic idea. The higher level class was dependent on the formats provided and didn't specify the formats, so they're highly coupled. So actually our solution was still highly coupled, because if we look at the use of this output formatter in this and some of the other examples, we'd see here that we were dependent on what was provided to us. So we needed to know about this. So there was high coupling between this class, our program class, our client class really here, and this output formatter. Okay, and we changed it slightly so that we had a concrete class that allows us to generate an object what we call the method, rather than using a static method like here and some of the other examples. I'm not sure which one it was, maybe OCP. But anyhow, when we work with abstractions, really, we're going to work on the high-level model of our system, and that's the point in this. And from this perspective, we only care about the behavior we want and not how it's implemented. So also when we talk about details up here, where does it say this? Details should not depend on abstractions. Abstractions should not depend on details. When we talk about details, we're actually referring to low-level modules, okay? And they're different to the abstractions in that they've been developed to solve a very specific problem, okay? Their scope is limited, and they typically specify a bounded unit or some subsystem. So we saw an example of this dependency earlier, as I said, when we removed the outputting of the messages to another class. We solved one issue, the single responsibility principle, but in reality, we just introduced another issue. So the output formatter, or the details class here, used in the main or the client class, just program, was determining how the client class behaved. So later we moved anyway from the static method, as I said, to an instance method, and we could change the dependency by introducing a message. Okay, so that was something we just did, but that didn't solve the problem. So really, we could change the dependency by introducing a messaging interface and specifying then that the output behavior utilizes a messaging interface, meaning that we could utilize any kind of message that implements an interface, so we could try this. So there's a good example that I have based on I've been basing my examples on here in .NET for All. If you look at this article, it's really good, goes through all the principles. I have similar examples. They're different in some ways, but I just made them a little bit different. But so while these are very clear, I think the example for ISP breaks SRP. So from my perspective anyway, it breaks it. It calculates the volume and writes the message. So it does two tasks, and it brings us back to SRP. And so I wanted to show you an example whereby you could introduce DIP and not break SRP. So I'm trying to look at an alternative example here that works. So we're going to start with some messaging interfaces and the concrete classes. So we start with a messenger here, and it has a message. And it takes a message, which is a number. And then we have a JSON message class now, instead of just a method that was embedded, and it implements the messenger class, and it writes something out in JSON format, and then the information is passed here. And then we have another class then that implements a text message, and another class that implements an HTML message, and they're all iMessenger. Okay. So in our program, which is the client, we want to be able to implement and determining at runtime which messenger to use. So let's create an iMessage message. So you see message here is actually an instance of the interface iMessenger and not anything else. And then this message, at this point, we create a new message, okay, a HTML message, and then we just use this message to write the message we want to display. We also call it like this, say a new text message, we could say a new HTML message or JSON message. And in lectures in a little while, we start talking about when to use new and not new and all that kind of stuff. So it's a nice way to do this. It shows you that we have now got our client, which is this program, talking to its low-level classes, the details here, and is doing this by specifying that we're going to send messages. And we don't worry about, we're happy to implement messages, okay? We don't matter which message is called, okay? And this could work as well if we're having a method that sends or utilizes something in a different class or a low-level class. In other words, implements the details. Okay, so that's it. This is the last one. Now there's lots to do about dependency and version principle. You do lots and lots of articles, and if you want, I can send you some and post some using more complicated, more detailed examples. But if you get this one, you understand what's happening. It's about this decoupling by using interfaces, and in other words, abstractions in some way. Sometimes they're called contracts. And then the whole point of this is that they high-level modules then communicate with the low-level. It doesn't need to know how to do it. It just needs to know that they do it in a particular way for us. Okay. So that's the last one in Solid, and I'll leave it there. Thank you very much for watching.